Model selection for business needs. Choosing the right tool for the job. Model selection for business needs. Imagine you were building a house. You wouldn't use a hammer to dig the foundation, right? You need the right tools for each job. The same is true for using models in your business. Understanding what you need, the problem. What's the challenge you are trying to solve? For example, maybe you want to predict which customers are most likely to buy a new product, or identify patterns in customer reviews. The goal. What do you want to achieve? Do you want to increase sales, improve customer satisfaction, or make better decisions? The data. Do you have enough information to build a good model? Do you need to collect more data? Example. Let's say you want to predict how many people will visit your website next month. Problem. Predicting website traffic. Goal. To plan your marketing budget and make sure you have enough resources. Data. You might need historical website traffic data, information about upcoming marketing campaigns, and maybe even data about the economy. Though, selecting the right model type. There are different types of models, like those that predict numbers, like website traffic, those that classify things, like good vs bad reviews, or those that generate text, like writing marketing emails. Choose the type that best suits your problem. Performance. How accurate does the model need to be? Some models are more accurate than others, but they may be more complex and require more data. Resources. Building and running a model takes computer power and time. Make sure you have the resources available. Example, for predicting website traffic, you might use a model that forecasts numbers. You could use a simple model that looks at past traffic patterns, or a more complex one that considers factors like seasonality and marketing campaigns. Testing and fine-tuning. Test different models. Try different models on your data to see which one performs best for your specific problem. Improve performance. Once you have a model you like, you can tweak its settings, called fine-tuning, to make it even better for your needs. Example, you might try different forecasting models on your website traffic data and see which one gives the most accurate predictions. You could then fine-tune that model to be even better at predicting traffic for specific months or for different marketing campaigns. Using and monitoring your model. Put it to work. Integrate the model into your system so you can use it to make decisions. Keep an eye on it. Models aren't perfect. They need to be checked regularly to see if they're still accurate and make sure they're still meeting your goals. Example, you could use your traffic prediction model to help plan your marketing budget for the next year. You'd then track how accurate the model's predictions were and make adjustments as needed. In short, choosing the right model is like choosing the right tool for the job. By carefully considering your needs, testing different options, and monitoring its performance, you can use models to make your business better.
Understanding business requirements. Understanding business requirements, the foundation of model selection. Think of building a model for your business like building a house. You can't just start hammering nails without knowing what kind of house you want. Understanding your business requirements is like drawing a blueprint for your model. Here's how to do it. 1. Define the problem. What's the challenge you are facing? Imagine you own a clothing store. Your challenge might be understanding why customers buy certain clothes and not others. What do you want to improve? You want to understand customer preferences to better design your store layout, offer more attractive sales, and create better marketing campaigns. Though, identify desired outcomes. What results are you hoping for? You want to see an increase in sales, better customer satisfaction, and more effective marketing. How will you measure success? You can track metrics like website traffic, sales numbers, and customer feedback to see if your model is helping achieve your goals. Data availability. What information do you have? Do you have customer data, sales records, website visits, social media interactions, or reviews? Is the data good enough? Is it accurate, complete, and relevant to your problem? If you want to predict customer preferences, you need data about what they've bought in the past. Example, let's say you want to build a model that recommends products to customers based on their past purchases. Problem, you want to increase sales by providing personalized recommendations. Outcome, you aim to see a higher click-through rate on recommended products and an increase in sales. Data, you need customer purchase history, browsing data, and maybe even information about their demographics, age, location, etc. In a nutshell, understanding business requirements is about clearly outlining what you want your model to achieve and making sure you have the right data to make that happen. It's the first step to building a model that truly solves your business problems.
Define the problem. Imagine you're trying to solve a puzzle. Before you start fitting the pieces together, you need to understand what the picture is supposed to be. Defining the problem is like figuring out that picture. In business, a problem is something you want to fix or improve. Here's how you define it. 1. What's the issue? Think about the specific challenge you are facing. For example, our website isn't attracting enough new customers. We're losing money because our shipping costs are too high. Our sales team isn't reaching out to the right people. Though, how does this affect your business? Explain the impact of the problem. This helps you understand the importance of finding a solution. Example, if your website isn't attracting customers, you are losing potential sales. This could mean less revenue and a smaller customer base. Teen, what do you want to achieve? Think about your desired outcome. What will your business look like once the problem is solved? Example, instead of, our website isn't attracting enough new customers, you might say, we want to increase website traffic by 20% and generate 10% more leads. Char, what information do you need? Think about the data you'll use to solve the problem. Do you have customer data, sales figures, or website analytics? Example, to increase website traffic, you might need data on what keywords people are searching for, where your current visitors are coming from, and what pages on your site are most popular. Defining the problem is the first step in finding a solution. It sets you on the right path to success.
Identify desired outcomes. Identifying desired outcomes. What do you really want? Think of desired outcomes as the goals you want to achieve using a machine learning model. It's like having a clear picture of the finish line before you start running a race. Here's how to find your desired outcomes. 1. Ask yourself, what problem am I trying to solve? For example, are you trying to predict customer churn? Finding out which customers are likely to stop using your service. Identify fraudulent transactions. Finding out which transactions are likely to be fake. Improve product recommendations. Suggesting products that customers are more likely to buy. 2. Be specific about what you want to achieve. Instead of just saying, improve customer satisfaction, be more specific. Increase customer retention rate by 10%, reduce false positive fraud alerts by 50%, boost product recommendations click-through rate by 20%. 3. Make your outcomes measurable. Your desired outcomes should be things you can track and measure to see if your model is working. Example, imagine you want to improve customer service by predicting customer satisfaction. Problem, customers are not happy with the service they receive. Desired outcome, increase customer satisfaction by 15%. How to measure it? You can track the percentage of customers who give positive feedback after interacting with customer service. By clearly defining your desired outcomes, you'll be able to choose the right machine learning model and measure its success in achieving your business goals.
Data availability, the fuel for your model. Imagine building a car. You need the right materials, right? The same goes for building a machine learning model. Data is the fuel that powers your model. What does data availability mean? It's about understanding how much data you have, what kind of data it is, and if it's good enough to train your model. Let's break it down. How much data do you have? Quantity matters. Think of a recipe. A simple recipe needs a few ingredients. A complex dish needs many ingredients. Similarly, more data usually means a better model. If you are building a model to predict customer spending, you'll need lots of past spending data. Example, imagine predicting if a customer will click on an ad. You'd need tons of data about past clicks, user demographics, and ad characteristics. What kind of data do you have? Data types. There are different kinds of data like text, words, numbers, images, or videos. Choose the right kind for your task. Example, want to predict customer reviews? You'd need text data about reviews. Want to categorize pictures? You'll need image data. Is your data good enough? Quality counts, garbage in, garbage out. If your data is messy or inaccurate, your model will be unreliable. Example, imagine a dataset about customer ages. If some ages are incorrect, like 150 years old, it will confuse your model. In short, data availability is about 1. Having enough data. The more data, the better your model can learn. Though, having the right type of data, choose data that matches your task. Team, having clean and accurate data, clean up any errors or inconsistencies. Think of data availability as the foundation of your model. Just like a strong foundation makes a sturdy building, good data makes a powerful model.
Model selection criteria. Choosing the right model. Model selection criteria. After you understand what problem you are trying to solve and what kind of results you want, it's time to pick the right model. This is like choosing the right tool for a job. Here's how. 1. What kind of model? Think about what your model needs to do. Do you want it to write text, like a language model? Do you want it to create images, like an image generation model? Do you want it to predict something, like a forecasting model? Choose the right model type. A language model is good for tasks involving text like writing summaries, translating languages, or generating creative content. An image generation model is good for tasks like creating artwork, designing logos, or even helping doctors diagnose diseases. A forecasting model is good for tasks like predicting sales, customer behavior, or stock prices. Though, measuring success, performance metrics. How will you know if your model is doing a good job? You need to measure its performance. This is like grading a student's work. Choose the right metrics for your task. If your model needs to be accurate, like predicting the weather, accuracy is a good metric. If your model needs to find all the important things, like finding all the spam emails, recall is a good metric. If your model needs to be precise, like suggesting products a customer might like, precision is a good metric. Theme. How powerful does it need to be? Think about how much data you have and how much processing power you have. Complex models need a lot of data to train and a lot of processing power to run. Simpler models need less data and can run on less powerful computers. Choose a model that fits your resources. If you have a lot of data and powerful computers, you can use a more complex model. If you have limited resources, you might need to use a simpler model.
Model type. Choosing the right model type. The building block of your AI solution. Imagine you are building a house. You need a strong foundation, right? In AI, the model type is like that foundation. It determines what your AI solution can do. Here are some common model types and what they are good at. 1. Language models. These models work with text. Think of them as superpowered language experts. Example, a language model can help you translate languages, write different kinds of text like poems or emails, or even answer your questions in a natural way. Though, image generation models. These models work with images. They can create new images, change existing ones, or even describe what's in a picture. Example, an image generation model could create a realistic photo of a cat wearing a hat, or it could help you find all the pictures of cars in a big photo album. Teen. Image classification models. These models can tell you what's in a picture. They can identify objects, faces, and even emotions. Example, an image classification model could tell you if a picture contains a dog, a cat, or a bird. It could also tell you if someone in the picture is happy, sad, or angry. Char. Recommendation models. These models are experts at suggesting things you might like. They learn from your past choices and preferences. Example, a recommendation model could suggest movies or music you might enjoy based on what you've watched or listened to before. 5. Forecasting models. These models predict what will happen in the future. They use data from the past to make predictions about the future. Example, a forecasting model could predict how much product a company will sell next month, or how much traffic a website will receive. Choosing the right model type depends on your goal. Do you want to understand text? Then a language model might be a good choice. Do you want to create images? Then an image generation model might be the way to go. Do you want to categorize things? Then an image classification model could be helpful. Think of it like this: you wouldn't use a hammer to paint a wall, right? You need the right tool for the job. The same is true for AI models. Choose the right model type to build a successful AI solution.
Performance metrics. Performance metrics. How to tell if your AI model is doing a good job. Think of performance metrics as the way we judge how well our AI model is doing its job. Just like you get grades in school, AI models need ways to measure their success. These metrics help us understand if the model is making accurate predictions and achieving the goals we set for it. Here are some common performance metrics. 1. Accuracy. Imagine you have a model that predicts whether a customer will buy a product or not. Accuracy measures how often the model gets the answer right. If the model predicts 100 customers and it correctly predicts 90 of them, then its accuracy is 90%. Example: in a medical diagnosis model, accuracy measures how often the model correctly identifies a disease. Though precision, imagine you have a model that identifies spam emails. Precision measures how many of the emails the model flagged as spam were actually spam. If it flags 100 emails as spam, and 90 of those were truly spam, the precision is 90%. Example: in a search engine, precision measures how many results shown are actually relevant to the search query. 3. Recall. Imagine you have a model that identifies fraudulent transactions. Recall measures how many of the fraudulent transactions the model actually caught. If there were 100 fraudulent transactions, and the model caught 90 of them, the recall is 90%. Example: in a medical screening test, recall measures how many people with the disease were correctly identified. 4. F1 score. Imagine you need a model that balances both precision and recall. F1 score combines precision and recall into a single score. A higher F1 score means the model is better at both finding relevant results and avoiding false positives. Example: a model for detecting hate speech needs to be good at both identifying hate speech, recall, and avoiding mistakenly flagging harmless speech, precision. The F1 score tells us how well it does on both fronts. 5. Mean squared error, MSE. Imagine you have a model that predicts house prices. MSE measures how far off the model's predictions are from the actual house prices. Lower MSE means the model is more accurate. Example: in a weather forecasting model, MSE measures how far off the model's temperature predictions are from the actual temperature. Choosing the right performance metrics depends on the task your model is performing. Think about what you want the model to achieve and select metrics that reflect that goal. For example, in fraud detection, you'd prioritize recall to ensure you catch as many fraudulent transactions as possible, even if it means a few false positives.
Computational resources. Computational resources. The power behind your model. Imagine your model is a car. It needs fuel to run, and that fuel is computational resources. This means the computer power it needs to learn and work. Think about these things. The engine, processing power, this is like the engine of your car. It's how fast your model can learn and process information. A powerful engine, lots of processing power, lets your model work quickly, especially for complex tasks like analyzing huge amounts of data. Example: if you want to build a model that translates languages in real time, it will need a lot of processing power. The fuel tank, memory, this is where your model stores all the information it learns. A bigger fuel tank, more memory, means your model can store more information. Example: if you want to build a model that can understand a large amount of text, like a book, it will need a lot of memory to store all those words. The cost of fuel, hardware costs, you need to pay for the fuel, computer power, that your model needs. Example: powerful computers, like those used to train large language models, can be very expensive. So, how do you choose the right amount of computational resources? Think about your problem. If you have a simple task, you might not need a lot of resources. But for complex tasks, you will need more. Consider your budget. How much can you afford to spend on computing power? Look for efficient models. Some models can work well even with limited resources. By understanding computational resources, you can choose the right equipment and settings to make your model work efficiently and effectively.
Model evaluation and fine-tuning. Model evaluation and fine-tuning, making your model the best it can be. After choosing a model type, like a language model or an image generation model, the next step is to make sure it works well for your specific task. This is where model evaluation and fine-tuning comes in. Imagine you've built a robot to sort apples, but it keeps mixing up green apples with red ones. You need to test the robot and adjust its settings to improve its performance. Evaluate candidate models. Think of this as putting your models to the test. You'll have chosen a few different models that you think might be good for your job. Now, it's time to see how they actually perform on your data. Example, you are building a model to predict customer churn when customers stop using your service. You've chosen two different models. You'll test them on your customer data to see which one is better at predicting which customers are likely to churn. Though fine-tune selected models, even the best model might not be perfect. Sometimes, you can adjust its settings to make it perform even better. Think of this as tweaking the robot's sensors to make it more sensitive to color differences. Example, let's say the model you chose for customer churn prediction works pretty well, but it's not perfect. You might try adjusting the model's parameters, like the weight it gives to different factors, to see if you can make it even more accurate. Why are these steps important? Finding the best model, evaluating different models lets you compare their performance and choose the one that's best suited for your needs. Improving performance, fine-tuning lets you tweak the model to get the best possible results. Imagine your robot now can sort green and red apples with almost perfect accuracy. Remember, model evaluation and fine-tuning are essential steps in building a successful model. It's like testing and adjusting your robot to make sure it can do its job efficiently.
Evaluate candidate models. Evaluating candidate models, picking the best fit. Imagine you are shopping for a new pair of shoes. You try on several different pairs, looking at comfort, style, and price. You are evaluating each pair to find the one that's best for you. Evaluating candidate models is like trying on different pairs of shoes for your business problem. You've already picked out some promising models, like different styles of shoes, and now you need to test them to see which one works best. Here's how you do it. 1. Use your data. You gathered your data, like the information about customers or products. Now, you use this data to test each model. It's like trying the shoes on and walking around in them. Though, look at key metrics. You're not just looking at how the models look, like the color of the shoes. You are focusing on important numbers that tell you how well they work. These are called metrics. Accuracy, for example, if you are building a model to predict customer churn, if they'll stop using your service, you'd look at how often the model predicts correctly. Precision, this tells you how many times the model is right when it says something will happen. Recall, this tells you how many times the model finds all the cases where something happens. Teen, compare and contrast, you are comparing how each model performs on your data. Which model gets the best scores on the important metrics? Example, let's say you are building a model to recommend products to customers. You might test 3 different models. Model A predicts purchases based on what a customer bought in the past. Model B predicts purchases based on what other customers with similar buying habits bought. Model C predicts purchases based on a combination of past purchases and similar customer behavior. You would use your customer data to see how well each model predicts future purchases. Maybe Model C wins because it considers both past purchases and customer similarities. 4. Think about practicality. Finally, you also consider how easy it is to use each model in your business. Some models might be very accurate but take too long to run. Evaluating candidate models is like finding the perfect shoes for your business problem. You are looking for the best fit, considering how well it works and how practical it is.
Fine-tune selected models. Fine-tuning selected models. Making your model super smart. Imagine you've chosen a model that's pretty good at its job, like a student who's doing well in school. But you want it to be even better, right? That's where fine-tuning comes in. Fine-tuning is like giving your model extra practice and coaching to make it excel in a specific area. You adjust the model's settings, like tweaking the learning rate, which is how fast it learns, or adding more data related to your specific problem. Think of it like this. You want your model to recognize different types of flowers. It's already pretty good at identifying roses, but you want it to become a master of recognizing daisies too. You fine-tune the model by feeding it lots of pictures of daisies, along with labels that say, daisy. The model learns to recognize the subtle differences between a daisy and a rose. Here are some ways to fine-tune your model. Adjusting parameters. You can tweak things like learning rate, how fast the model learns, and the number of hidden layers, the complexity of the model. Adding more data. The more data you provide, the better your model will be able to learn and make accurate predictions. Changing the training process. You can modify the way the model is trained, like using different algorithms or adding constraints. Why is fine-tuning important? Improved accuracy. Fine-tuning allows your model to perform even better on your specific business needs. Enhanced performance. You can make your model more efficient and faster, especially if it needs to handle a lot of data. Tailored solutions. By fine-tuning, you can create models that are perfectly tailored to the unique demands of your business. Fine-tuning is like giving your model that extra push to reach its full potential. By adjusting its settings and providing more specific training, you can create a model that's not just good, but outstanding.
Deployment and monitoring. Deployment and monitoring, making your model work for you. After you've chosen the best model and trained it on your data, it's time to put it to work. This is called deployment. Think of it like bringing your model from the lab to the real world. Deployment is like connecting your model to your everyday work. It's the process of integrating your trained model into your workflow or application, so it can start making predictions and helping you achieve your business goals. For example, if your model predicts customer churn when customers stop using your service, you would deploy it into your customer relationship management (CRM) system. This way, the CRM can use the model's predictions to identify customers at risk and offer them special deals or support to keep them happy. If your model generates product descriptions for your online store, you deploy it into your website's content management system so it can automatically create new product descriptions. But even after deployment, your job isn't done. It's important to monitor your model's performance over time. This means keeping an eye on how well your model is doing in the real world. Think of monitoring like giving your model regular checkups. You need to make sure it's still working effectively and hasn't lost its edge. Here's why monitoring is important. Data changes. The data your model is trained on might change over time. For example, if you are predicting customer preferences, their tastes may evolve. Your model needs to stay up to date. Model drift. Sometimes, the way your model makes predictions can drift away from what it learned during training. This can happen if new patterns emerge in your data. Performance drop. Even a well-trained model can lose effectiveness over time. Monitoring helps you spot any performance drops so you can take action. So, how do you monitor your model? Track key metrics. Remember those performance metrics we talked about earlier: accuracy, recall, etc. Keep track of how they change over time. Compare predictions. Look at the predictions your model is making and see if they align with your expectations. Are they accurate and relevant? Set up alerts. If you see any significant changes in performance, you should get notified. This could be a simple email or a more sophisticated monitoring system. If you notice problems with your model's performance, you might need to retrain it. This means feeding it new data and adjusting its settings to get it back on track. In summary, deployment and monitoring are key steps in the model lifecycle. By deploying your model, you bring it into the real world and make it work for your business. By monitoring your model, you ensure it stays effective and accurate over time.
Deploy chosen model. Okay, let's talk about deploy chosen model in simple terms. Imagine you've built a really cool machine that can predict how many customers will visit your store each day. You've tested it, and it seems to work well. Now, you want to put it to use, right? Deploying the model is like setting up that machine in your store. It means making it available for everyone to use. Here's what it usually involves. 1. Choose a platform. You need a place to host your model. It could be a computer in your office, a cloud service like Google Cloud or Amazon Web Services, or even a special server just for your model. Think of it like a store shelf where you put your machine. Though, make it accessible. You need a way to get information into your model and get answers out. This could be a website, a mobile app, or even a special program that connects to your model directly. This is like putting a sign on your machine that says, "Give me information, and I'll tell you the prediction." Theme: set up security. Just like your store, you need to keep your model safe. You'll have to set up rules to make sure only the right people can use it. You might need passwords, access control, or other safeguards. Example: let's say you have a model that predicts how many customers will come to a bakery each day. You could platform host your model on a cloud service, like Google Cloud, so it can be accessed easily. Accessibility: build a website where people can enter the day of the week and get a customer prediction for the bakery. Security: make sure only employees with the right permissions can access the website and view the model's predictions. By deploying your model, you make it available to those who need it, and you can finally start using it to solve real-world problems.
Monitor performance. Monitoring performance, keeping your model on track. Think of your model like a new employer. You want to make sure they're doing a good job, right? That's where monitoring performance comes in. It's like checking in on your model to see how it's doing and if it needs any help. Here's how you do it. 1. Track key metrics. Remember those performance metrics we talked about earlier, like accuracy, recall, precision. You need to keep an eye on these numbers over time. Let's say you are using a model to predict customer churn when customers stop using your service. You might track accuracy, how often the model correctly predicts if a customer will leave. Recall, how many customers who actually churned were correctly identified by the model. Precision, how many customers the model flagged as churning actually did churn. Though, spot the trends, look for patterns in your metrics. Are they going up, down, staying steady? This helps you understand if your model is getting better, worse, or staying the same. Example: if your model's accuracy is decreasing over time, it might mean your model is not keeping up with changing customer behavior. Teen, act on changes. If you notice something's off, you might need to take action. Retrain the model. Sometimes, feeding your model with new data can help it improve its performance. Adjust model parameters. You can fine-tune the model's settings to improve its accuracy on specific types of data. Switch to a different model. If your current model is not cutting it, you might need to try a different type of model altogether. Char. Keep it simple. Don't get overwhelmed with complicated dashboards and charts. Focus on the most important metrics and visualize them in an easy-to-understand way. 5. Automate where possible. There are tools that can automate the process of monitoring your model's performance. This can save you a lot of time and effort. Remember, monitoring performance is an ongoing process. You need to keep an eye on your model's performance regularly to make sure it's meeting your business needs.